This tutorial is called Boost Your Productivity in FPGA and ASIC Design and Verification. My name is Bart Brosens, and since a little over 4 years, I'm an application engineer with Sigasi. That means I mostly support our users. Before that, I also was a user of Sigasi Studio myself. So in this tutorial, I'll explain something about how you can make your life as a designer easier and then be more productive at the same time. And that's whether you're writing projects in VHDL, Verilog, SystemVerilog, or also mixed language. So most EDA tools, like simulators or synthesis and place and route tools, they focus on the chip. So the result that they provide is aimed at the chip, but at the same time, they start or they assume you have correct code to start from. As a user or as a digital designer who's writing any of these languages, you should also take care of using the right tools to become more productive. So a while ago, I heard about a manager who didn't like these kind of tools because it made the designers lazy. But then I would say lazy is a good thing if it's done the right way, of course. Why should you bother with making sure the syntax of your code is correct? Why should you bother with copy pasting code and then modifying things if you can use a tool that will do all these things for you? That way, you can focus on the thing you're being paid for, and that's the design, not checking if the syntax is correct. So in this presentation, I'll handle 3 topics. I'll tell you how we think you can be more efficient when editing your code. Second part of this tutorial will handle how you can be more efficient when browsing through code, whether that's an existing project written by someone else or by you a couple of weeks or months ago. And thirdly, I'll talk about a VS Code extension that we're currently developing and how this can help you also obtaining better results. So for the first part, I look at how you can use a tool that gives you direct feedback while you're typing. Also about how you can have code checks that are language aware and that give you relevant feedback. And thirdly, how you can use an intelligent content assist, also called an autocomplete, to make it easier to write your code and write it not only faster, but more correct at the same time. So when you're asking direct feedback from your code, it's important that the feedback is also in your editor, the place where you're typing, and that there is no need to switch any context. So traditionally, with a traditional editor, you're editing your sources, you're running a tool, for example, VCon, to compile your code. The tool will report issues in your code, syntax errors, for example. You have to read those and you have to get back to your sources, find the correct place, edit your code to correct the issue, and all that takes time. It's even so that the further you go, so maybe your code does compile and you start simulating, but then later on when loading the design in the simulator or when running the simulation for a while, you hit an issue, then this feedback loop is much larger and much more costly because you have to spend all that time again after you changed your code. So having a tool that can avoid going through this feedback loop a couple of times can already be a huge time saver. The further you go in your design, typically, also the longer it takes to resolve this kind of issues. So the more you can resolve earlier on, the cheaper. So being lazy becomes being more efficient and costing less, having your code faster to the chip. So what is the solution? You get the feedback while you're editing your sources. That's something you should be aware of, that can be a great help. When we're looking at the language-aware code checks, there are two types of code checks. First of all, the validation, so checking whether your code is syntactically correct. Try to use a tool that tells you that while you're typing. It won't cost you anything to go, even not go back, but to move up a line and add that semicolon that you forgot, for example. The second approach is, or the second aspect is code linting. Even in syntactically correct code, there can be problems that can be checked by a tool very fast. So you have linters that take a while to run because they do a lot of checks that take a lot of time. On the other hand, while you're working in your editor or your IDE, also there you can have some fast lintings that help you see these problems immediately. There can be some programming errors, maybe some bugs in your code can already be discovered like this. One potential type of bug is using a vector assignment with a different width, where you will drop or forget some bits. Then in teams, it can be interesting to use the same style. You can have code style guides that require a certain naming style or indentations to use, maybe comments in the header of your files. If your tool can check things like that, code reviews that you do won't have to mention those things, because those will be correct when you start the code review, and instead you can review the actual functionality of the code instead of the stylistic errors that there might be. And also some suspicious or problematic constructs can be flagged this way, and that can also avoid to have bugs further on in your code, discover them at a later stage during a simulation, and having to go back to your source code at that time. When you're writing code, having an intelligent content assist can be very useful. So if any of these common language issues I mentioned in the previous slide are discovered, for some of them a quick fix might be available. That means with a few clicks of your mouse or a few keys on your keyboard, you can resolve these issues without having to type anything yourself. A content assist can also help with the consistent formatting of your code. If all your colleagues use the same formatting, it's way easier to read code written by your colleagues in code review of when you have to change that later on. If you have common declarations or statements in your code, which can be company specific, the use of templates for those is also a big time saver. You don't need to go to some library or other code and copy paste from there. No, instead you can have these templates in your code, and just using those templates then also is a big time saver. And then finally, and maybe the most important, is if you have the contents of your code available, and that they also can be automatically used when you're typing code. The most popular example for this is to use a single name when you're typing it, and you get a list of all the existing singles in your design filtered by what you're typing. That helps a lot to not make mistakes there also. And for example, when you're doing a component declaration or an instantiation direct or from a module in Verilog, things like that, the more automated these are, the faster you can work. So I'll briefly show a couple of these things in a demo. So the tool that you see here is Sigasi Studio. And so Sigasi Studio is built as an Eclipse plugin. It's built on top of Eclipse. And when you open Sigasi Studio the first time in a new workspace, you will get some tutorial projects, and it's also those that I'm using here to show some of the capabilities of this tool. I mentioned formatting, so when I right-click here, I select to format the source code, you see that this entity declaration immediately is much more readable. Here I have a warning. The warning tells that the declaration is unused. That might indicate that I forgot to code a part of my code. Here we have a warning on a process where there is an incomplete sensitivity list because it's also sensitive to the reset. So using a quick fix, I can add this missing reset signal immediately here. On the line of the reset, there is a C-type equality check, which in VHDL should just be a single equality sign. So all these things are checked while you're typing your code, and it's very easy to resolve them that way, especially because the issue is indicated in the correct location. Then if you look here, we have a signal of a specific type, and this type is an enumerated type with 3 elements. That will help me here when I want to start a finite state machine. I press Control Space after typing a few characters. I can continue to type. That won't make a difference in this small list. And now I can see any of the choices I have here, what the effect will be on my code. And because of the enumerated types we have here, those 3 literals, A, B, and C, I can immediately complete a case statement using these, and that's a good skeleton to start a state machine. Here we have another error. We're using a variable assignment here, but data out, as you can see, is a port, so that can also be easily fixed. If I go to this SystemVerilog file, you see that also here an issue is flagged where we have a missing parenthesis. I can format the source. Semantic highlighting also help you to check what is what in your code. Obviously, also regular editor features like things as a block selection mode can be huge time savers if you decide to change vector widths for a bunch of logics at the same time. Another autocomplete example I can show you is when you want to insert an always block. Pressing Control Space will show you all the possible completions. You select the one you need. The CLK is not used here, but if I start typing and I press Control Space, you see that we automatically insert this clock input here. Another regular editor feature, you select a bunch of lines and you can move them up. You can do the formatting again to have the indentation correct in this example. If you want to comment out a bunch of code, it's easy if you can do that at once. And then also you might want to format it again. So things like that help you to be more efficient when dealing with your code. It requires less context switches, and that keeps you more focused on the target of what you're doing. You're implementing functionality. It's not your job to spend too much time on checking whether syntax is correct or not. So I'll stop this small demo here. And then I'll continue with the second part of this tutorial, and that's about code browsing. What can help you is that whenever you see something, an object in your HDL code, and you want to know what it is or where it's been declared, you should be able to quickly navigate to there. So then it's a good idea to have hyperlinks and have a way to jump to the source of those hyperlinks. What I've already briefly shown in the previous demo, maybe there is no need to navigate. If you can have a hover that is showing information, then you immediately have the information at hand where you want it, and you even don't have to spend time navigating to a declaration. And finally, as a third subpart of this section, maybe there is more than the editor. There can be additional views to give you more insight in your project, in your design. Meanwhile, I see a question. While editing, is it possible to select vertically a column to edit? So yes, it is. So if I go into block selection mode, which is activated by pressing Shift-Alt-A, and you see my cursor is a cross now, then I can select entire columns and edit the contents there at once. It also helps to maybe remove these or add them all at the same time. Okay, my pleasure. So to continue with the second part, when you're working on your code and you select an identifier, it's a good idea that you can jump to the declaration. So you can do that in various ways. Either you right-click and in the pop-up menu you select to open the declaration. Without a mouse, you can just press F3 to jump to a declaration. And while you're browsing, you can also press the Ctrl key, and all of the design elements will become hyperlinks, and you just Ctrl and click the identifier to navigate. You can also use the back and forward keys to go back and forward in your history of browsing. So this should work just like a web browser, and that allows you to quickly go through a project. Also, if you don't know it, you can almost automatically find whatever you need. Then maybe that's even not needed. So if you hover over an identifier, you should be able to see a tooltip showing information about the data object you're hovering over. And then there is even no need to navigate away and come back. In this example, we have a state variable. If you hover over it, you see that it's a variable of the state_t type. And even more handy is that also this type declaration itself. So for state_t, you see it's an enum type, and these are the literals of this enum type. If there are some useful hyperlinks, that can also help. So you still can go to the declaration, or you can search for references so you can find any occurrence of this state variable. I see another question. So is this based on Eclipse or VS Code? So what I'm showing now is all based on Eclipse. What we're doing in VS Code is very similar, and that will be part of the third part of this tutorial and the demo I'll give them. Up to the next slide. I told you there is maybe more than the editor that can provide insights. So depending on what aspect of the project you want to focus on, there can be different views that help you, or different kinds of views. In this screenshot, I've listed a few. So there is an outline view that you might already have seen in the demo, a hierarchy view that was also present, a problems view, and on the left side, a libraries view. I'll go a bit more into detail in the next slides. And in this screenshot, there also is a dependencies view that shows you the relationship between different files in your project. So the idea of these different views is not only to give you more insight, but to help with navigation. It should be possible to navigate from a view to an editor. Also, if that is in a different file that is not yet open in an editor, you should be able to click on an instantiation or on a problem report to open an editor and immediately go to the corresponding location of the code in that editor. The other way around, sometimes it might be useful that the view follows the editor. So in a lot of cases, you can have a link between the view and the editor that you can enable. And if it's enabled to link, the view should highlight and follow the element being edited in your editor. So a few different views that are available. We'll see those in the next slide. So, and in the first slide, we have the outline view. So the outline view was available on the top right in my demo. And this is a bit more into detail. So it will summarize libraries that are present in the active editor, entities or modules and architectures from the editor. Also then within an entity or a module, ports or the signals within an architecture or a module. And then also an overview of different assignments, instantiations, and processes or always blocks that, that might be present in an architecture or a module. And so navigating should be as easy as double-clicking here and having the editor jump to the correct line position in the code. A bit more high level is the hierarchy view. So the hierarchy view can correspond to a view similar to the outline view, but then of your entire design. This requires that you set a top level, you indicate in the user interface what architecture or what module will be the top level of your project. And then below those, you can have an overview of all instances, assignments. There is a little bit of filtering, so it's good that you can maybe to make this more clear, to only show instantiations and don't deal with assignments here. Contrary to the previous view, to the outline view, the hierarchy view will span multiple files. So your design can have a hierarchy spanning multiple files. So then here you can also click to open a different file. So if you click the hierarchy view, the correct editor should open in a correct location. And on the other hand, if there is a link between the hierarchy view, actually that's this icon with the two yellow arrows. If this link is enabled, then the hierarchy view should also highlight where you are in an editor. Another example of a view is the dependencies view that can show all dependencies between a file in a or between the different files in your project. It's a good idea there to have a scope that can be configured and also the level of detail that can be configured because this view can be very large. In this example, you also see the design elements within a file. It might be useful for clarity that you disable showing the design elements and just have the files. This also shows relationships within a project. You see here that we have an orphaned file, and this is a cluster of dependent files. And here we have another cluster of dependent files. Maybe you just want to see the files on which your active editor is depending. That's also something that can reduce the number of files here. And as you see, for VHDL projects, then that's especially interesting, having the ability to split up files according to in which library they have been mapped and still show the relationships between those. That can be a good thing too. And so this can also be a huge time saver if you see a file on which you're currently working, and that's depending on another file, you want to have a look there, you just double click to open the editor in the correct location. The next view is a libraries view. So again, that's probably more useful for VHDL than for Verilog. On the other hand, we are using the concept of library mapping also in Verilog, just to make the distinction between which files should be analyzed and which files are not relevant for the project. In VHDL, obviously, that can be used a lot more to separate your design or different IP blocks in your design in different libraries. And for example, you can avoid naming conflicts that way. So also here, if you can navigate from a design element within the library to the actual location in the editor, that can be a huge time saver as well. When you open a project and there are some or a lot of errors, it's always a good idea to be able to have an overview of the issues in your code. And that way you might be able to prioritize which issues to resolve first in your code. So it's a good idea to have an overview of all the problems. On the other hand, there might be a lot of problems here if you just start opening an existing project, and it might be interesting to also be able to filter here. If there are quick fixes available, like on the light bulbs you see here, it might also be a good idea that you can apply this quick fix from within this view. That way you might be able to resolve issues without even having to open the editor. A next view is the tasks view. So a lot of people, and I think it's good practice, when you're working on something and you're not immediately ready to finish something, you add a to-do or a fix me tag, or maybe something else that should be configurable in your tool. And at some point, you want to have an overview of all the open issues, things you know that you still have to do in your code. So having an overview of all those tasks and being able to navigate to them in the editor is also a very good idea. Specifically for SystemVerilog, when you're dealing with classes, where you have derived classes and members within a class, being able to navigate through the hierarchy of the classes and to the declarations from this view to the editor, that can also save you time and give you a nice overview of how the classes in your SystemVerilog projects are structured. And also when you're working with Verilog and using the preprocessor, there might be some unexpected things happening because of the preprocessor, resulting in weird compiler issues. Then it's always a good idea to be able to see what the compiler is seeing. So the preprocessor view here should show you what the code, what your code is looking like after it has passed the preprocessor. So the macros are expanded, also included files are effectively included in this view. So this, what you see here is just virtual. It's not really existing on a file in your project, but it's what the compiler eventually will see as an input. And if the focus of these two views, so the editor and the preprocessor view, is linked, and you scroll in one or select some code in one, that should also be visible or selected in the other view. A more graphic view and a graphic representation of a project can be a block diagram. So the signals passing from ports to instantiations, or signals between processes and instantiations, all those things can also be graphically represented. that gives you a good mental image of how a block of code is looking. This architecture, for example, has a process labeled counter. There is a generate statement that instantiates a number of subblocks that is displayed this way. And when you click here, it should be possible to navigate to your code so that even if this is a very large file, the block diagram might be more concise and should also help as a navigation instrument to find the correct or to find the relevant code in your editor. And it might be useful that you also can modify what is visible here. So if you have a lot of instantiations, you might want to group them together. If you have a bus, you might want to group a bunch of wires together to make that more readable. That's also a useful feature. And then these diagrams can also be used in your documentation. When you're working with state machines, having a dedicated view to represent the state machine can also be very helpful to get a good mental image of what you're writing here. So it's easy to see the transitions between the states themselves, to navigate by double-clicking here to the code, to the actual transition or state declaration in the case statement we have here. And this can also help to avoid bugs. You expect maybe a transition from stand to run. That's not very visible in the code, but here you see the transition is missing. So then it's very easy to navigate to your code and to add that transition. And again, if you can use this in documentation, that's also a very useful thing. So I'll again show a few of these views. Maybe I'll start with the state machines. So here you see that there probably is an issue with the waiting state. If I double click, I navigate to the type declaration here. Let's click the arrow left to go back. And the issue is also visible here in this error. So not all the cases are being covered, and there is a missing choice, namely the waiting state in this case statement. So just by hovering here, let me scroll a bit down and you can see it. So I can choose to add a missing choice, and at the bottom of the case statement here, you see the waiting state has been added now. It's still a dead state because there are no outgoing transitions. So let's fix that. I can press Control Space to have less typing. Also here, Control Space completes the state. And now you see, while I was typing, the diagram did get modified, and the waiting state now has a transition to the idle state. So if I want to check out the idle state, I can just double click here, and you see that my cursor now moved up in the code. Actually, there is another issue here. We have an almost ready when clause that is not visible here, but there is also an error. So there is no declaration for almost ready. If I hover here, I see the same error, but I have the option to apply a quick fix and to declare a new enumeration literal. So as soon as I click here, the almost ready literal is added here. And if we navigate back, you see that the almost ready state also is visible now in the state machine diagram. And the transition from almost ready to ready, I can double click and we navigate in the code there. So meanwhile, you also see the problems view we have here. So the problems listed here come from both projects. It's interesting that you can filter for a single project, and then you only see issues from the project you have open. The same way here, I can quickly navigate to an issue, resolve the issue, You see the red marker here has been grayed out, and when I save the code, the marker disappears, and also the issue disappeared from the problems view. There is one view I haven't shown yet in the presentation. I'm going to show that first, and that is documentation view. So this view will show a preview of how the exported documentation will look like. So if you can export documentation from your projects with a few clicks automatically, that also can save you a lot of time. But you want to know what will be listed in the documentation. So in this example, we have a module that you can see here. There are a lot of, or some ports and a lot of wires declared, some parameters. That's this one. And maybe you, this is Verilog. You want to add some documentation as a comment here, and that will show up in your documentation in this table. It's also interesting if you can add a description that shows up in a description subject here. So what happens here, it's in a different file. So you see that the documentation view shows you a preview of all these files and what happens. And also, well, the comments that are added to the documentation depend on where you're located. It's also an interesting thing that in the comments here, you can have, or you can use Markdown. Just a quick example. If I use double stars for bold, but you can also have italics, lists, numbered lists, or bullet lists, and even tables in Markdown. So your comments make your code more readable, even if you're using Markdown here, and all that will be used in documentation that you can export. So that's also a huge time saver. I think I've shown most of the views that are available. The format for the exported documentation is HTML. Let me quickly show it. So there are still issues, but I'll be able to generate the documentation. So what you see here is that we now are generating the documentation for this Verilog tutorial. And you saw all the graphics show up, so block diagrams, state machine diagrams, and also a dependency diagram of this. And so in here, you can navigate using the hyperlinks in HTML then. And it's also possible to style the HTML using some custom CSS by just placing it in the root of your project. And what you also could do is import HTML in Word and use a Word macro. We actually have that, an example of that available on our website, or you can just contact us for a pointer to it. So now up to the final part of this tutorial session. The VS Code extension I want to talk about. I'll mention a few things about how we can learn from the software world. I'll briefly explain what and why we are using the language server protocol, and then I'll show you where you can try this yourself. So some people say that tools for software development is about a decade ahead of hardware development. That might be true because the software industry is much larger by number of engineers. So it probably pays off more to develop tools for software engineers. There is a wider market, so there will be larger investments. But that allows us as hardware developers to adopt proven practices from the software world, also in hardware development, and you're doing that already. You're probably using version control, linting or code coverage, and also unit testing with tools like VUnit becomes more popular. So those practices come from the software world. So it's a good thing, and it's natural to catch up with those trends from the software world in the hardware domain then. Traditionally, when you want to support a language in a certain editor, you needed to have a specific plugin or extension for that editor for your language. So if you want to support VHDL in VI, you have to develop a VI plugin to support the VHDL. The same if you were doing so for Atom or Visual Studio Code, which are the three icons here on the right. So that's a huge effort to support different editors with the language tools you're developing. So Microsoft originally made the suggestion for the language server protocol, but it has been adopted by many people. And that allows to decouple the knowledge about the language from the editor that you're using. That means that you can create one server, one language server to support, in our case, hardware description languages. And then you just need a client, an LSP client for every of the editors. And the actual effort, which is in the language server, does not need to be repeated. The integration is done by a much smaller client for the LSP protocol that plugs into the editor. So LSP is a unified protocol from the IDE or the editor to the server, and it allows an editor to become a real IDE by supporting or providing better support for different languages. So LSP itself is just a high-level message protocol, and it defines a few typical operations or requests that you can do about a document, where your cursor is, what range is selected. The protocol itself also doesn't bother about which editor or IDE it's being used in, or for which language. So it's really a neutral intermediary. It does need to cover typical operations from an IDE. So when you hover over something, the instruction of what should be displayed in the hover should be transported by this protocol. Also, when you're invoking autocomplete or content assist, when you're jumping to a definition, checking errors, or all common things that you want to do in an IDE. The servers themselves, they should provide rich capabilities, but not necessarily all of them. So you can start developing a server with some limited capabilities and maybe extend those later on. So in the low-level communication is based on a JSON protocol, so where you have standard message structures and sequences. If you want to learn more about LSP itself, there is a good website, launchserver.org, that I recommend you to have a look at. In our example, we've developed an extension for Visual Studio Code. So the specifics for Visual Studio Code are limited, and the bulk of the work, the bulk of the knowledge we have at Sigasi is in the language server. Visual Studio Code itself is a browser-like application that's free to use, and there are a lot of plugins. There is a huge ecosystem with plugins that you can use, and there are also numerous languages supported, some through LSP. So while you have most of the editing capabilities, the nature of Visual Studio Code itself is much more lightweight than, for example, Eclipse is. Originally, this targeted smaller projects and was very popular for web front-end parts. There are some other references, other editors. At this time, we do not support any plugins for those. But so in theory, it should be possible to support a minimal plugin combined with the server through LSP then. I know of users who have written their own Vim plugin and are using that in combination with the R language server. So the Sigasi language server then makes that in VS Code we can support SystemVerilog, Verilog, and VHDL, or a mix of those in a project. And the language server itself will then analyze your code still at type time, and will also give the instant feedback like we're used to and like I showed before. And on top of that, it provides autocompletes, error messages, and also navigation information. You can hover and see some context, just like I showed in one of the previous slides. And it provides also semantic highlighting. A little warning there, because it really depends on the VS Code team, whether everything is supported by the team. So you should be careful there. Currently, our VS Code extension is in beta, and you can learn all about it by going to our website, sigasi.com/vscode. And it's also possible to try this yourself. I've prepared a small demo. I'm going to show here. So this is the page of the extension. When you open a VHDL file or a Verilog file in VS Code, the extension is available from within the recommended extension list. The first time you install the extension, you will need to make sure to configure your license path here. We do offer free trial licenses, so no problems there. And then once you open an HDL file, so a VHDL file or a SystemVerilog file, the extension will launch and you will get feedback in a problems view like this one. It's always interesting to have a look at the output. You can here select Sigasi output or even the tracing output from the server communication. And here you see that the language server has been started and that the client has connected. And then you can navigate your code. You can update your code. You can here press Control Space for the autocomplete. The first time you open it, there will be a tutorial project like this one. And also when you press Control Shift P, you start typing Sigasi, you can ask to create a demo or tutorial projects. On the right-hand side, actually that's a view I forgot to show in the previous demo of Sigasi Studio in Eclipse then. There is a minimap that's visible by default here. So it's also available in Sigasi Studio. And when you create a project here, a language version.json and a library mapping.json file will be created. If you're familiar with Sigasi Studio, then note that this is slightly different from what we're doing in Sigasi Studio. But this is still a beta and we're working on unifying that approach. If you're not familiar with VS Code, you should know that the command palette, which you activate by pressing Ctrl-Shift-P, really is your way to go. So any comment you're looking for, you press Ctrl-Shift-P and you start typing. And that's a very straightforward way to navigate to a lot of different places. Here, let's right-click I can ask to format the document. The key shortcut here is different than it's in Sigasi Studio because this is the VS Code default, and also tricky on Linux, what I have here. The shortcut is different than on Windows. So formatting code works, and this actually is done by the language server. So if I hover here, also the hover information is returned from the language server. Here we have a warning. You see the problem here in that hover. So that signal should not be in the sensitivity list. We can correct it like that. At this time, we don't have quick fixes yet, but that's something that that also will come in the future. And so here we again have the unused declaration. That's similar to the previous example. So I think we can add that here. And then once you have a case statement using the state type, that warning also will be gone. Let's look at some other issues. That's an interesting one. So this is using a different library. We currently do not have that library in our project. You can see that here, there just is the work library. Let me put that on the right side. So in the my lib folder, I right click on it. I ask to set the library. Then we choose to have a new library and we call it my lib. So this is very similar as Sigasi Studio, just a little more manual at this time. And now this issue is gone and we can press Control click or hover, but now I'm going to click to navigate to the declaration here. So here we also have an incomplete sensitivity list warning, a dead state because of the state machine that we've analyzed. It's, I think, the same state machine as before. And then here we have a couple of warnings, signals that are not yet being used, but they will be gone also once you use these. Actually, they are being read but not written. So I see a question: where is the server location and how to keep the code safe? So this server is really local. It's just part of the VS Code extension, and that is containing the server. Actually, in software development, that's a next movement to be able to use a central server, and I can imagine that in a lot of companies it's even considered more safe that you have your own in-house server and people connect to that server to work on the code. And actually, in combination with the VS Code Remote SSH plugin, that already is possible with the Sigasi extension. But when I talk about the language server, that's really just running on my machine in this case. It's a sub-process of the VS Code process. So you can try all of this yourself. You can download Sigasi Studio from our website. The VS Code plugin is available from the VS Code marketplace and can be installed from within VS Code itself. And when you need a license, please go to our website, sigasi.com/try, and request your free trial license. So it's a license that's valid for 1 month. So thank you for following the presentation. And if you have questions, you're very welcome to ask. Okay, I see a question from Mustafa. Does Sigasi work with external EDA tools like Vivado, Questa? So the answer is yes. Let me briefly show that. So in the preferences view here, you can configure various tool chains for different things. For example, when you configure the Vivado XSIM installation path, you can use this to compile your code whenever you save your file. while Sigasi is compiling it while you're typing. So the external tool, Xsim or QuestaSim, Riviera, they can compile your code whenever you save. So, and you say, I don't want to open Vivado IDE while I'm working with this editor. So yes, that's possible. So you can work on your projects in here, and you, well, depending on how you further run the compilation and the place and route, you could even do that using a script. And once you have these scripts, you can launch them from within Sigasi. The next question is how does Sigasi deal with design sync? I'll have to Google because I'm not familiar with design sync. Maybe if you can clarify your question.
Hi, Bart. The design sync is like the SVN. It's kind of like a management, film management.
Yes.
System.
Okay. Thank you. Thank you. Well, then it depends on whether or not there is an Eclipse plugin available. Sigasi Studio itself, by default, comes pre-installed with the eGit plugin. So that helps dealing with Git repositories. So you can right-click and then use the theme menu to commit or compare. And in a similar way, so I'm just navigating to our manual here, and then let's look at the third-party plugins. So for revision control systems, there already are a number of Eclipse plugins that you can install in Sigasi Studio, and that way you can use those from within Sigasi. But I'm not aware of any design sync Eclipse plugin.
Okay, thanks.
Yeah. On the other hand, if you're using VS Code, then it's a matter of having a plugin in VS Code. So also there, I think Git support is available in VS Code, and you have some additional plugins.
Yeah, thank you.
Okay, thank you for your question. Are there any other questions?
Hi, Bart. This is Muhammad Ibrahim. I'm not sure if I missed this part or not, but I don't know if I can access my design files. That's not in my local machine. I mean, I have some files. It's remotely located, and I'm wondering if I can navigate or I can browse or open these design files in Sigasi.
Yes. And do you have SSH access to the remote location?
Yeah, sure, yeah.
Yeah. I'm not really sure about Eclipse, but there might be a plugin there that allows you to remote into a server and handle your code there. On the other hand, VS Code almost has that natively. It might be a plugin actually, but there is a very good extension that allows you to use SSH, and on the local machine you don't really have the files. And if you happen to run VS Code from within the Windows subsystem for Linux, for example, that is very similar. So then you have your plugin on the server, and you have local access to your files, and the plugin is running on the remote server.
Okay, great. Yeah, thank you. Another question is regarding the linting feature of Sigasi. Let's say, for example, if I have RTL code, and in this RTL code, I have some technology-dependent component that it will should be handled as a black box. So what is the situation then? I mean, how it will make linting for this?
Yes. Can I use the Vivado Unisim library as an example, is that relevant?
Exactly.
Okay. So for that kind of libraries, we recommend to link them under a common libraries folder. So in a VHDL project, you will always have that, but you can add that kind of folder also in a Verilog project. And then Sigasi Studio analyzes the content of that so that the contents are available for auto-completion, but we will not check this for errors. So there will be no syntax checks or lintings on the files within the common libraries. So that allows you to use, for example, an I/O buffer from the Unisim within your code and using auto-completion. And you can also even navigate to the source code there. So as a brief example, let me open a VHDL file. So it's like clicking here, and then I navigate to a file here. So whenever you configure the Vivado installation path, we know how to link in, for example, the Unisim library in the common libraries, because that can be done with a quick fix.
Okay, good. Yeah, thank you.
Thank you. Another question from Mehmet is if Sigasi supports HLS design files. I would say no. So we're really focusing on VHDL, Verilog, and SystemVerilog code. If on the other hand you have an HLS tool that is generating Verilog code, maybe you could use Sigasi to browse through that code. Does that answer your question? At this time, we do not have plans for that now. To support HLS in the future, there is still plenty to do on what we're trying to do right now. Okay, thank you for your question. So if there are no more questions, I see it's already past 6, then we can conclude this tutorial. Thanks again to everybody for joining, and I'm looking forward to see your questions. So if you still have some, then you can contact me on support@sigasi.com or on my personal email address. But with technical questions, I recommend to use the support address. There are colleagues reading that in my absence. So thank you, everybody, and enjoy DVCon tomorrow. And have a nice evening.